All right, so let's start with something really simple, okay? So as you know, this unit has been all about patterns, how things are repeating itself. So now we have a little pattern, and I want to see if you can figure out the pattern here. So the first row is this, and then I'm going to write this one right here. And then the following, no, sorry, my bad. No, I mean this, okay? So this is the second row. And then the third row is this. The third row. And then the fourth row, it's next one, it's 1, 3, 3, 1. Now you might have seen this before, but I want to, if you have not seen it before, if you forgot what you have seen before, that's fine. So let's just take a look in here and see if you can recognize any kind of pattern. So the following row would be 1. And then 4, and then will be 6, and then 4, and then 1. The following row would be 1, and then 5, and then 10, and then 10, and then 5, and then 1. How many of you think that you have the pattern figured out? All right, so if you think you have the pattern figured out, what's the next number? 6, and then 15, and then 20, and then 15, and then 6, and then 1. All right, and then just do one more. So the next one would be 1, and then 7, and then 21. Yes. 35. Yes. 35 again. Yes. And then wait, hold on. 21, right? It's Friday. 21, 7, and 1. What's the pattern? So you add 2 numbers here, you add 2 numbers here, and then you add 2 numbers here, and then just keep on. Well, it's like a funnel, but it's actually getting bigger, bigger, bigger. Anyone knows the name of this triangle? Huh? No? It's called the Pascal's triangle. Okay, Pascal's triangle. Now, so this is something that I remember I learned this not from the teacher at the very beginning. It was just some upperclassmen back in the middle school, high school days, and they were like, I guess they're trying to show off how cool something is. I was like, oh, that was cool. I remembered it, but I never knew where it is used until later that I knew, like, oh, that's where you use it. Cool. And we'll use this today, okay? But before we do this, before we go into any of the work, so I want to share something more with you. So yesterday I was looking at Pascal's triangle, getting ready for today's lesson, and I was looking up, like, what's the history of Pascal's triangle? I want to know the history of it. And I found something. Okay, I found something. I want to share something with you. So I found a little wiki page from a university. I have no idea which university it is, but some good graphics. Like, oh yeah, well that's a cool way to show how the numbers are coming together with hexagons. But that's not the coolest. That's not the coolest thing. Like the colors, cool, but not the coolest. They have a nice little GIF file to show you the actual work of how the numbers are coming together. Okay, that's a good illustration. Well, I found out that well, Pascal's triangle is actually not well. I mean, it's by Pascal, but not he's not the first one. Okay, I think it sets before. Well, despite the fact that the triangle is named Pascal's triangle, the pattern was known long before Pascal wrote his treatise. The first explicit description of Pascal's triangle was by Halayuntaha, an Indian commentator, and also from not long after in Persian, and then a Chinese mathematician. So people in the people way back then, they knew something like this. Again, that's not the coolest thing yet. What is the coolest thing? I saw this picture. If you add the numbers horizontally, the numbers in blue, that's a total. And can you see something special about the numbers, the total? What are they? 2, 4, 8, 16, 32. What are they? They're what? The power of 2. 2 to the first power, or 2 to the 0 power first, and then 2 square, 2 to the first power, 2 square, 2 cube, 2 to the 4th power, 16, 2 to the 5th power, 36, 2 to the 6th power is 64, and so forth. And I was like, wow, that I didn't know. That was cool. And there's more. 11, the number 11. What's 11 square? 121, right? I think most of us know that. Wait, 121. That's 11 square. Can you guess what 11 cube is? 1,331. Now that to me, it's a little bit mind-boggling. I was like, wow, it was not even related to 11, but somehow it works with 11. So that to me, I think it's a little bit crazy. Okay, exponents of 11. So just want to show you something extra that Pascal triangle. It's kind of cool. If you ever come across with Pascal's triangle again, and you can share with people. Now you might be thinking about like, what's going on here. They actually show you some work like how do you deal with 10. That's how they deal with 10 over there. Okay, so well. For us, we'll just get back to the Pascal triangle and the application of it. Okay. Now, on your page, on your packet, so you have the Pascal's triangle on the very last piece of paper. Now you can see that it goes all the way to 1, 5, 10, 10, 5, 1. What I want you to do is to go ahead and write 2 extra rows. And I'm going to move the triangle away so that you are not copying. I want you to actually write down the numbers. Okay. What are the 2 rows of numbers?